Hello and welcome. My name is Tom Exelby. I'm head of cybersecurity at Red Helix. In this role, I work with our clients who sit across multiple sectors, working with them to secure their digital environments against known and future threats. Red Helix are a managed security service provider who specialize in delivering comprehensive cybersecurity solutions for small to medium-sized businesses. We're a trusted defender of UK businesses, providing enterprise-grade security tailored for SMBs with a strong emphasis on compliance, scalability, and affordable protection. Our team focuses on offering personalized local service and peace of mind, making us an indispensable partner for businesses seeking growth without fear of cyber threats. I'm very pleased to be talking to you today about cybersecurity for critical national infrastructure. I will focus on the unique challenges of securing CNI and dive into two areas where some significant risks can be mitigated. This diagram depicts a typical CNI digital ecosystem. The diagram serves to represent the busy complexity and broad spectrum of technology, tasks, and users which make up the digital infrastructure. Although I've used a stereotypical cooling tower, this could just as easily represent any other type of CNI, ranging from ports to hospitals, and in my experience, I've found that the key tenets I will cover remain the same. Based on the diagram, we can tease out the characteristics which make protecting CNI digital landscape so tricky. CNI systems are inherently interconnected and have broad dependencies. A breach in one CNI sector can have cascading effects on others. For example, a cyber attack on a power grid could disrupt transportation, healthcare, and communication systems. CNI systems often rely on a highly complex supply chain, consisting of third-party businesses interacting with critical digital systems. This increases exposure by making them vulnerable to attacks originating from those third-party vendors and suppliers. The Dragonfly attacks in Ukraine in 2014 and the US in 2017 provide stark reminders of how criminals can rapidly exploit the interconnectedness and complexity of CNI supply chains. As the building blocks of modern society, providing a reliable and available service is fundamental to operating CNI. Its systems provide essential services that cannot easily be disrupted. Downtime caused by a cyber attack can have consequences for public safety, economic stability, and social security. As a result, CNI organizations rightly invest heavily in expensive redundancy and backup systems, which in turn are vulnerable to attack. Many CNI systems rely on legacy technologies, which could include risk-to-life operational technology or monitoring systems. Upgrading these systems can be challenging due to costs, compatibility issues, and the risk of disruption. These systems can create a very real risk as a weak point in security architecture. With a broad workforce and highly flexible structure, involving contractors and other third parties, the human factor plays a significant part in security. Strict access management causes a unique challenge as well as social engineering attacks. Despite training, humans are fallible to making errors of judgment and process, all of which can cause significant issues. With these points in mind, I want to expand on the current threat landscape. There's never been a more dangerous time to be operating online, most significantly when harnessing the advantages of remote control and monitoring of operational technology. Threats to CNI have grown substantially since the US attack on the Iranian nuclear facility in mid-2010, known now as Stuxnet. Since then, the successful modus operandi demonstrated by Stuxnet has been copied by multiple actors to cause harm and disruption to CNI operations. And this is most commonly seen in Ukraine. The kill chain follows a similar path. First, lengthy and extensive reconnaissance is conducted to ensure accuracy when deploying and releasing the cyber weapon. Once released, the code is designed to multiply and spread autonomously throughout the systems in search of its target. For Stuxnet, it was looking for programmable logic controllers, which were moderating the speed of the centrifuges within the facility. Of note, this type of control system is still widely used in CNI today. The subsequent danger of this behavior is if the code escapes from the network onto the wider internet, thus allowing the code to continue to replicate on its hunt for a target. So, even if your operational technology is not the target, Rogue code meant for a different target could still disrupt your operation. The level of sophistication seen in this type of malware is most likely attributable to nation-state actors who are highly skilled and well-funded. It is important to note that CNI is also still the target of ransomware attacks. Your employees are targets for advanced phishing campaigns, and this is still seen as the easiest way to gain entry to a network by cybercriminals, leveraging the human factor. So, not only are CNI operators fighting against internal industry pressures, they are also some of the most talented nation-state sponsored cybercriminals trying to put a spanner in the works of the operation. Based on trends that we've discussed and the complex characteristics we are working with, I would now like to focus on 2 areas where you can reduce risk and make things harder for an attacker. But before moving on, it is important to discuss the foundations of good cybersecurity. If we think of cybersecurity as a building, the foundation must be solid or everything else will be at risk. In cybersecurity, the basics are that foundation. No matter how advanced our technologies or sophisticated our strategies are, without mastering the basics, we leave ourselves vulnerable to significant threats. So, what are these basics we're talking about? At the core, they include regular software updates, patch management, strong password policies, user awareness training, data backups, and strong access controls. All of these must be nestled within an established security culture. Neglecting these basics is like ignoring cracks in a building's foundations. Cybersecurity attacks often exploit the simplest vulnerabilities, such as an unpatched system or a weak password. A failure to get the basics right can lead to breaches that compromise critical infrastructure, causing widespread disruption, financial loss, and even threats to national security. Now we've touched on the basics, we can move on to the first focal point, which is securing the supply chain. And I've included some stats which highlight this as being an increasing area of concern. On top of doing the basics right, security architecture must consider building effective deterrence. This will aim to make it more difficult for cybercriminals to gain access to your systems. Strict access controls, which work on a zero-trust basis, are an important measure to consider, especially with a transient workforce of contractors, technicians, and service providers. Working with your supply chain, you should look to cascade compliance to standards through service-level agreements. The implementation of NCSC guidance, along with the new NIS2 directive, is an important step forward for securing supply chains. It also demonstrates a committed and diligent approach towards security. The NCSC's guidance offers a robust framework that emphasizes risk management, incident response, and the importance of secure by design principles. NIS2 complements this by imposing stricter regulatory requirements, including mandatory risk assessments, supply chain audits, and enhanced reporting obligations. Together, these measures will not only enhance our ability to identify and mitigate risks across the supply chain, but also ensure a unified and resilient approach across the entire sector. This alignment between national guidance and European regulations is critical in building a resilient infrastructure capable of withstanding both current and emerging threats. Building a network of partners allows CNI security teams to vet and recommend trusted security providers to the businesses in their supply chain. If these businesses deploy the service you have recommended, you have the assurance that they are covered by a known and trusted security solution. This will reduce risk in line with the confidence you have built in the service. MSSPs provide an integrated service package consisting of a combination of the best and most appropriate technology available in the cybersecurity market. Their expert analysts build a broad knowledge using different tools and monitoring a variety of clients. This experience adds significant value when applied within your security ecosystem. MSSPs will work with your security teams to deploy a scalable and cost-effective security solution. Relationships can be forged between security teams in the supply chain and within CNI to share intelligence and experience. These relationships can also be used to detect and alert on compliance issues within the immediate supply chain. We at Red Helix pride ourselves in delivering a comprehensive and professional service as described. We will work across your supply chain as portfolio of companies and ensure a consistent level of protection is delivered through our managed detect and respond service. Our UK-based Security Operations Centre is dedicated to protecting businesses around the clock. We combine industry-leading endpoint detection and response, network detection and response, and security information and event management technologies to deliver a comprehensive and powerful solution, which is accessible for all. Our clients benefit from seamless integration, being part of a large user base and dedicated expertise. The service is scalable to ensure that even the smallest participant in your supply chain can achieve enterprise-grade security. This level of conscious and detailed monitoring and detection is what is required to combat modern techniques such as those seen with the SolarWinds attack in 2020. If the worst should happen and a breach is detected, having a detailed and rehearsed incident response plan is critical. This can be developed in conjunction with your partnered MSSP as well as specialist response partners. These partners will be able to provide detailed analysis of point of entry, intended target, and give an understanding of what level of compromise has occurred. They will then be able to look at recovery of systems and processes to bring your business back online. All the while, they can be closely working with your insurance provider and legal teams. Completing the ecosystem, the measures taken to involve an MSSP in your supply chain, detailed response planning, compliance to regulations will all contribute to reduced downtime and lower insurance premiums. Another tool in our arsenal for securing the supply chain is Zero Trust Network Access. This is especially applicable for C&I and its diverse and fluid workforce. This technology, often referred to as ZTNA, is a cybersecurity model that fundamentally shifts how we think about network security. Unlike traditional security models, such as virtual private networks, that assume everything inside the network is trustworthy, ZTNA operates on the principle of never trust, always verify. ZTNA starts with the assumption that no user or device, whether inside or outside the network, can be trusted by default. This means that every access request must be authenticated, authorized, and encrypted, regardless of where it comes from or what resource it's trying to access. Users and devices are granted the minimum level of access necessary to perform their roles. This reduces the potential attack surface, limiting what an attacker can do if they gain access to your network. ZTNA involves dividing the network into smaller segments or microsegments, each with its own security controls. This way, even if an attacker breaches one part of the network, they can't easily move laterally to other parts. ZTNA isn't a one-time check. It involves continuous monitoring and verification of user behavior, device status, and access patterns. If anything seems unusual or suspicious, access can be automatically restricted or revoked. As previously mentioned, this can be part of an MSSP's service delivery. By removing the assumption of trust, ZTNA significantly reduces the risk of unauthorized access. Even if an attacker compromises one part of the network, they'll have a hard time moving to other parts. Zero Trust Network Access is a powerful approach to modern cybersecurity, especially as organizations increasingly rely on cloud services and remote monitoring. By shifting from a trust but verify to a never trust, always verify model, ZTNA helps organizations protect their networks and data in an era of evolving threats. Understanding what and why things are attached to your network provides critical visibility to build security upon. It also actively defends against a common attack vector, especially when operating closed networks such as system monitoring or critical systems. This is the next topic I want to cover. Network visibility is the cornerstone of effective cybersecurity in critical national infrastructure sector, particularly when it comes to mitigating the risks posed by rogue devices. As a key component of ISO 27001 and NCSC CNI guidance, network visibility is an expansive topic. Without comprehensive visibility, we are essentially blind to the full scope of our network, leaving gaps that can be exploited by unauthorized or compromised devices. Rogue devices, whether introduced maliciously or inadvertently, can act as entry points for attackers, facilitating lateral movement and data exfiltration. To counter this, it is imperative that we implement robust monitoring tools and provide real-time insights into all connected assets, including those that deviate from expected behavior. Continuous network scanning, anomaly detection, and automated alerting ensures that any unauthorized device is swiftly identified and isolated. By prioritizing network visibility, we can maintain control over our digital environment, significantly reducing the attack surface and enhancing our overall security posture. To hone in, there have been some useful advances in technology which cover this portion of security. Having a system which monitors traffic, access, and assets is important. These sorts of discovery tools are quite commonplace, especially in expansive networks infrastructure such as CNI. However, there are a new brace of security products which now delve deeper into the heart of hardware components connected to the network to truly understand if they are who and what they say they are. This innovative change in the market combats the evolved threat of rogue devices, which is only expanding as industry exploits the advantages of modern operational technology and Internet of Things. Rogue devices are simple, small computer systems which innocuously plug into a network. They're coded to behave as trusted devices such as a printer or a camera. All the while they are deploying malware or conducting reconnaissance on your vulnerabilities. The objective of such a vector could be to flood servers to cause disruption with a DDoS attack, exfiltrate data, or compromise industrial control systems. But traditional inspection systems, looking at the MAC address, network management protocol, or vendor ID, would allow them to operate, as it believes they are a trusted device. However, modern DNA fingerprinting would instantly scrutinize the electronic signatures of the device, such as resistance and impedance. If the signature does not match the expected readings, then the technology will immediately disable the port and block access, all before damage can be done. This provides a level of detection and response not previously attainable against this type of attack vector. The technology is of exceptional value in closed networks where direct or wireless connectivity is the most likely method of entry for criminals. By way of a summary, getting the basics right is key. If you're lucky enough to have an internal security team, they will be tracking a wealth of metrics to keep abreast of the basics. Partnering your team with a trusted MSSP such as Red Helix can allow them to focus on wider security controls and away from day-to-day network monitoring. Bringing this all together with your supply chain will not only make compliance easier, it will also provide greater levels of assurance which you can convey to your customers, board, and employees. No one wants to be a victim of a cyber attack, especially with CNI, when the implications can impact the wider public. But if you have drawn in all the expertise available and built a layered security ecosystem, you will be making your network an extremely difficult target and not only limiting the likelihood to an attack, but also limiting the impact. The threat landscape and characteristics of CNI have never made it more difficult to build and operate a secure network. But I hope that my insight into two areas which can reduce your exposure and risk are useful when considering measures to take and controls to put in place. I'm happy to take any questions or for anyone to reach out to discuss this topic further. Thank you for listening.